Hello everyone. So today we're going to study about blockchain ecosystem. And yeah, I know I've heard a lot of reviews. I've seen a lot of reviews. I've read a lot of reviews where people are telling me to read from the PPT and then explain it with analogy. So I am going to abide by that in this video and let's see how it comes out. So moving on to the next slide that says blockchain ecosystem. So blockchain ecosystems are essentially described as a collection of components capable of interacting with one another and their environment to produce a set with desired particular qualities. That is to say, just think of a blockchain ecosystem as a living organism. All the different organs in the body, all the, internal organs, external organs, they work together to keep us alive. A blockchain ecosystem is made up of multiple components, nodes, smart contracts, miners, users that all interact together and keep the blockchain alive. And their collaboration is what creates specific outcomes, let's say trust, let's say decentralization, let's say transparency, let's say security. So I hope you're getting it right. And blockchain is a decentralized ledger that generates an open and shared database of transactions or records that cannot be disseminated across other networks or changed retrospectively without a large majority of the network's users. So at its core, blockchain is just like a digital notebook that's shared with everybody in the network. What is the difference then? Nobody owns it. It is decentralized and nobody can secretly rewrite it. To change anything, most of the network has to agree, right? Because if 51% of the network is not agreeing, the change cannot be made. That's what makes blockchain so trustworthy, tamper resistant, and transparent at the same time. So, a blockchain ecosystem can also be described as the established governance structure for a particular use case. So, beyond technology, every blockchain ecosystem runs on rules. It's governance model, right? Because just like a city, it needs laws and regulations to enforce safety for every citizen, to ensure, everything is going by law. So here also we have a governance model that is needed to define how participants will interact, what are their rights, what decisions they can make, how are they going to resolve conflicts, how are they going to reach to a consensus. And this governance ensures that the ecosystem works smoothly for its intended purpose, whether it's finance, whether it's supply chain, whether it's healthcare, everything is taken care of. So the governance structure outlines participant expectations for conduct, data ownership, finance, eligibility requirements for entry and exit, and the terms under which participants may share information. So the governance is very specific. It decides who can join the system, what data are they going to own if they join the system, how financial transactions will be carried out, how would they be handled, and even how members can exit the blockchain. So it's basically the rule book of the ecosystem, which builds trust because everyone knows the boundaries, everyone knows the expectations, everyone knows their limits, everyone knows the rules that have been defined for everyone in the system, right? With this, let's go to the components of the blockchain. The first we come with application node. Every machine with an online connection needs to download the specific internet program in order to join a blockchain ecosystem. A user joins the blockchain network once they have installed the node application. One can take part in the ecosystem after installing a node application. All lines mean same though. But think of the node application as your entry ticket to the blockchain. It's like if you have to join a meeting, you need to download Zoom, right? Without it, you simply can't join it. So once installed, your computer becomes part of this network and you're officially inside the blockchain ecosystem, able to interact with others and participate in activities like validating transactions or just accessing information. Next component, we come to spreadsheet ledger. This is both the logical element of the data structure that the node program manages. One can access the corresponding ledger contents from that ecosystem once the node program has been installed. One may run as many node programs as they choose, provided that they're legal to use and each will take part in its own blockchain environment. So imagine this like a massive Google Sheet that everyone in the network can see, but no single person controls because it is totally decentralized. The node software manages this shared spreadsheet called the ledger. By installing the node, you get access to view and use this digital ledger, which stores all the transaction history of the blockchain. Just like you can install multiple apps on your phone, use them. You can run multiple blockchain nodes on your computer. Each node links to its own blockchain world. For instance, you might run a Bitcoin node, and also you can run an Ethereum node side by side, each participating in its separate ecosystem with its own rules, with its own community. So that is what is spreadsheet ledger for you and me. Then let's come to consensus algorithm. The node application in the blockchain ecosystem incorporates the consensus algorithm. They lay forth the groundwork for the ecosystem's transition to a single ledger view. Different ecologies get a consensus in different ways. Different consensus algorithms such as proof of work and proof of stake, POW and POS, each requires nodes to be honest in their own specific ways before they can join the consensus building process. Since we have many nodes spread across the world, spread across the network, how do they all agree on a single version of truth? Because if they don't agree, we cannot append any block to the blockchain. And that's where consensus algorithms comes in. They're like referees that ensure everybody is following rules, everyone's copy of the ledger is matching, and that no one can sneak in false information. So each blockchain they have their own style of reaching agreements. It may be proof of work, it may be proof of stake, it may be delegated proof of stake, Byzantine agreements. For example, proof of work, right? It makes the nodes solve complex puzzles, right? And then proof of stake, it requires nodes to lock in some of the tokens as a guarantee of honesty. And different ecosystems choose different rules. But whatever be the case, the goal is always the same, that is to reach consensus. That is to maintain trust through consensus. Then let's come to virtual machine. Virtual machine is a simulation of the computer environment that was built by a computer program and run using instructions written in a programming language. The node application is implemented concurrently with the virtual machine. For instance, the EVM, Ethereum Virtual Machine, is housed inside the node program in the Ethereum blockchain ecosystem. So what is a virtual machine? It is just like a mini computer that is running inside your own computer. It creates a safe environment where blockchain code can run without interfering with your actual system's code. For Ethereum, this is the Ethereum virtual machine, goes by EVM. It allows smart contracts, little pieces of code to run automatically across the network, giving Ethereum its power beyond the transactions. So it's just like a mini computer that is running inside a computer that does not disturb your computer but has its own environment to run blockchains. Next, coming to the another components that goes by blocks. Blocks are just the basic data structures that form the blockchain, and each block is going to hold information. Each block will be appended after consensus is done into the blockchain, and they're identified by unique hash, and also they hold the hash to the previous block. That is why how we get to know that the tampering has been done, because we're connected. All the blocks in the blockchain are connected to each other using the address of the previous blocks. Node is an authorized user of the blockchain. A person with a computing machine can participate in the building and mining blocks in the blockchain network. Hash is just the unique key that identifies the block. Previous block hash, the hash address of the previous block to which the current block is actually connected. Private key, a cryptographic version of identity, a unique identifier of the candidate, and can enable a person to perform a digital signature. Public key, a cryptographic key which helps to identify a node in the blockchain network. Peer-to-peer network is a network that we use for blockchain that is decentralized. Transaction, any action in the blockchain is called a transaction. So it is basically an interaction which involves an information exchange in terms of Bitcoin investments, video content sharing, medical record processing. A set of transactions form blocks containing information specific to a transaction. These represent the current state of the blockchain. Miners, the nodes which participate in the validation of the new blocks or transactions. Consensus mechanisms, how they all agree. Process by which the miners validate a block. Proof of work, proof of stake, delegated proof of stake, Byzantine's agreement. Network tokens, the cryptocurrencies, for example, bitcoins, can be used to incentivize blockchain transactions in monetary terms because nobody is so kind to validate your transaction. Smart contracts can be thought of a piece of code where all the rules are predefined to govern a transaction, and it is signed with the help of a private key. These are digital forms of legal contracts. Cryptocurrency, yet another use case built in blockchain technology. Within a few lines of code, you can create a code that identifies a physical good, real estate, asset, or access rights. So all these components are just the components of blockchain and how they're used, where they're used, what are the linking mechanisms, what are their other process mechanisms. We're going to study them one on one, right? For now, you just need to know what is each, right? Just the real life definition of each of them, and it works for you for right now purpose. Now let's come to the blockchain ecosystems. We have three of them: private, public, and consortium blockchain ecosystem. Let's start with the private blockchain ecosystem. As the name says for itself, a private blockchain ecosystem limits access to a certain participant group that has been given the authorization to join and conduct transactions on the network. So unlike public blockchains where anyone can just hop in the network, a private blockchain is like an exclusive club. You don't get entry until and unless you have a valid pass. You need invitation, you need approval to enter. Only authorized members can join, which makes it ideal for organizations that want control over who can access their network. To keep track of a shared ledger and expedite activities within a closed network, it is often employed by corporations, associations, or consortiums. Private blockchains are very popular in the business world. So imagine a group of banks or healthcare providers who all need to share information securely. So you know what? Instead of sending endless emails or depending on external systems, they use a private blockchain to maintain one shared ledger that ensures speed, that ensures accuracy, that ensures trust, without like letting the outsiders in. Now you'll be wondering, how can speed? You know how it is about trust. Okay, because we're not letting everybody join in. How is it about accuracy? How is it about speed? Now let's see. We're going to see in the same slide. Let's just go ahead. Private blockchains have a regulated membership and require permission to join, in contrast to public blockchains where everyone can participate. So the key difference is public blockchains, they're open to everyone. Anyone can just hop in the network. Let's say Bitcoin, let's say Ethereum, they're public blockchains, right? Whereas the private blockchains, they handpick their members. Their permission structure means there's a clear gatekeeper who will validate whether you can join the network or you cannot join the network altogether. And because there are a few participants, then in a public blockchain environment, the consensus techniques utilized in private blockchains are frequently more effective, more scalable. So since a private blockchain only has a selected group of participants to reach agreement, to reach consensus, they are more fast. Instead of thousands of anonymous nodes competing, a smaller trusted group makes decisions. That makes the decisions more accurate, more trustworthy, more fast. So now you're getting it. Why in this way we are ensuring speed, we're ensuring accuracy, we're ensuring trust. Makes sense? So this makes private blockchains more efficient, more scalable for business processes. Coming to the public blockchain ecosystem. This is a distributed ledger system without constraints and permissions, right? Anyone with internet access can sign up on a blockchain platform to join the network as an authorized node and become a part of the blockchain. So public blockchains, they're just like the open playgrounds. Anybody who has a bat can come and just do their batting. No permissions, no gatekeepers, just an internet connection is enough to join. This openness allows anyone, anywhere to become part of the network, ensuring maximum transparency and decentralization. So it is permitted for a node or user who is part of the public blockchain to view recent and old records, confirm transactions, or complete proof of work for an incoming block and engage in mining. So once you join, you're not just a passive observer, you can participate. You can look at all past and present records, help validate transactions, and if you have the right resources, even mine the new blocks. It's a community driven effort where power is spread among all the participants. There is no gatekeeper who is going to check in that if do you have the valid entry pass or you don't have. Anybody who has a network connection is allowed to use the blockchain, is allowed to mine the blockchain, is allowed to hop into the blockchain network. Then, the mining and trading of cryptocurrencies is the most fundamental usage of public blockchains. As a result, Bitcoin and Litecoin blockchains are the most widely used public blockchains. So, the clearest example of public blockchains is cryptocurrency. Bitcoin and Litecoin are household names because they are built on public blockchain systems. These platforms allow anyone to mine coins, to trade them, sharing the power of open, borderless financial network. If users adhere to security policies and procedures to the letter, public blockchains are generally secure. However, it is only dangerous when the participants don't really adhere to the security rules. So, public blockchains, by law, by letter, they're designed to be secure. But that security depends on participants, because anyone, anywhere in the world can join in the blockchain network. If users follow the rules and best practices, the system is safe. The system is safe. But if they don't do, the system becomes unsafe. Because if they get careless, reusing weak passwords, ignoring basic safeguards, the risk of hacks or frauds, they just increase manifold. Then last blockchain ecosystem, that is consortium blockchain ecosystem. It is basically a hybrid architecture that combines the advantages of both public and private blockchains. Right. So consortium blockchains are like the best of both worlds. You get the openness, you get the shared access of public blockchains, while you get the control and privacy of the private blockchain. This makes them especially useful for groups that want collaboration, but they also want to set some limitations, to set some boundaries. So it entails a consortium of organizations or companies coming together to jointly manage and oversee a blockchain network. Due to the fact that the consensus process is shared among the consortium members, consortium blockchains provide a compromise between decentralization and control. So you just have to picture a group of banks or even a partnership between government bodies, between government companies. Instead of one entity holding all the power, now they share responsibility for managing the network. This way, no single member dominates, but it's also not completely open like a blockchain. There are a group of banks, there are a group of companies who are the participants. So the balance lies in governance, which is not kept to a single member, but which is kept in the shared companies, right? So the members of a consortium can come from different backgrounds. They may be for these members may be for profit businesses, governmental organizations, or other groups with similar objectives. While still providing for a distributed and shared ledger among trustworthy users, consortium blockchains offer greater privacy and scalability than public blockchains. Obviously, because the group is defined now. So the members of a consortium can come from different backgrounds altogether, maybe businesses, maybe regulators, maybe non-profits. But the key is that they all share a common goal. Everybody sharing a common goal. Now there's a group that has the governance. For example, logistic companies may form a consortium blockchain to track shipments globally, ensuring trust, transparency across the supply chain. And all those companies now come together for it. The strength of a consortium blockchain is that it maintains a distributed ledger, so no single entity can tamper with the records but limits participation to the trusted members. This design boosts privacy, efficiency while remaining more scalable than fully public blockchains. So, in simple words, it has best of both the worlds. Openness and sharedness of the public blockchain combined with privacy and control that is provided by the private blockchain. So, with this, in the next video, we're going to see about centralization versus decentralization. Thank you so much. And if you could extract 10%, 20%, or you found the video helpful in one or the other way, just go like the video and subscribe the channel. Bye bye.